Okay, good afternoon, students. Okay, so here would be our online lessons. Okay, so for X4 Draw Feed, Unit 2.2. Okay, so this is our third part. We're going to continue our study on like the fluvial processes. Ah, I forget to change the background of the previous section. Okay, so let me change the background first. Okay. Okay, so today we're going to talk about another part of fulfill processes. And before we have talked about erosion, okay, today we're going to continue about the transportation and also deposition. So you can see that, okay, so this background I choose that would be like underwater. Underwater. I hope you can understand that. Like under the river, this is the river, under the river. So actually, there's lots of what we call like the bed load, okay, bed load there. And there will be different kind of fulfill processes, okay, fulfill process. And before we talk about like the erosion, I hope you still remember like abrasion, solution, attrition, and also hydraulic action. Okay, so these are the erosion. And then today we're going to talk about like transportation. For transportation, that will be easy. It is because from the name of just this term. Okay, so you will know that what would be the process. Transport. Okay, it means uh, the load would be taken from one place to another place, and that's it. Okay, from one place to another place. So that would be like a transportation. So therefore, okay, right now let's have a look. So what would be the transportation in the river? Okay, you may have your textbook. Okay, you may have your textbook. Okay, let me change the background first. Okay, change a little bit. Then you may still see the bed load. Okay, in the river. Okay, so you may turn to like page 25. So we're going to continue our previous study. Okay, how does a river carry its load? Okay, carry, that would be the main purpose of our discussion today. So we want to talk about the process transportation. It means the water in the river that would carry the load. Okay, so let's see. So there are three main types of river load: dissolved load, suspended load, and also bed load. Okay, so what are they? What are they? So this time I'll use my sketch notes to do the explanation. So for the bed, oh no, okay, so I should say this. For load, okay, for load from your textbook, so we can divide it those load into three types. Okay, three types. They are dissolved load. Okay, they are dissolved load. Okay, with a load, they're dissolved load. They are suspended load, and also bed load. Okay, from the name of this three type of load, okay, dissolved, suspended, and also bed, you can see the nature. You can see the nature. You can see the characteristic of what are those load. Dissolved load, okay, so it means that it could be like some mineral. It can be dissolved in the water. Okay, it can be dissolved in the water. Okay, so mineral can be dissolved in the water. Okay, and suspended. You may understand that. So they are actually very small. Okay, they are actually very small. And if I draw the cross section of the river, okay, if I draw the cross section of the river, suspended load, it means that it could be suspending, okay, in the water that's flowing. And then the last one, bed load, that is relatively large. So therefore, where are those bed load? So if I draw the cross section of the river, bed load, of course, that would be at the riverbed. So therefore, from your textbook, you can see we can divide those load into like three types. Okay, then, okay, so what would be the movement? What would be the movement about those load? So when we talk about like the movement, those movement, remember we would call it transportation. For the process of transportation, we can divide them, or we can classify them into four types. Okay, namely suspension, traction, sortation, and also solution. These four types. So first, I will talk about the fourth one, solution first. Solution first. Here, yes, here. Solution. Solution. What? or how this transportation process that may occur. Okay, and or you may ask, what type of load, okay, what type of load that would be suitable for this process? That would be for the soluble minerals, okay, minerals. So it means that when those mineral that is dissolved in the water, okay, those mineral will carry, oh no, those mineral would be carried away by the river, by the water, from one place to another place. And this process, we would call it solution. So therefore, when the soluble mineral are dissolved and carried downstream, so therefore, solution. And that's it. Okay, so that is not complicated. That is not complicated. Okay, then what would be the next three? Okay, so the next three, they're called suspension, okay, traction, and also sortation. So for this one, I'm not going to explain those processes according to the sequence in your textbook. So I would talk about traction first. Traction. Okay, and after my explanation, you will know that why I would have that kind of sequence. Okay, so traction, what would be like traction? Traction, it means like large and heavy boulders and rocks are rolled, okay, so please highlight rolled, rolled it and dragged it along the river, rolled it and dragged it along the river. Okay, so what does that mean? What does that mean? For traction, it could be like this. If we draw, okay, the river, that would be the cross section, okay, and you can see the river. Of course, there would be the riverbed. Okay, the first one, okay, the first transportation I'm going to talk about, traction. Okay, there must be large and heavy boulders. Large and heavy boulders. Okay, how would these large and heavy boulders that moved in the river? It rolls. It rolled. And then, okay, it would move downstream. It would move downstream. And this one, okay, so of course, there must be along the riverbed. We call it traction. Traction. So what type of load, okay, what type of load that may use the process of traction, okay, for transportation? Just now we mentioned that is mainly for the bed load. Bed load, as it is heavier and large. Therefore, the water or the river may not be strong, or they may not have high energy to lift those boulder, okay, a little bit higher. That's why those boulder, they may just roll, okay, they may just roll along the riverbed, roll along the riverbed, okay. So that is the first one, traction. Okay, then the second one. So the second transportation I will talk about, that is sortation. Okay, sortation. So in your textbook, sortation here, the second one. So what is sortation? That is when small stones and pebbles bounce. Okay, please highlight the word bounce. Bounce in Chinese, you may understand like 弹 bounce along the riverbed. So what would be sortation? Okay, that could be like this. So this time for sortation, smaller rocks, or just now mentioned in your textbook, pebbles. Okay, pebbles. Okay, like this, small pebbles. So also on the riverbed, but how they moved, they bounce. So it means okay. So along the riverbed, so they would move a little bit further. So compared to traction that's just rolled on the riverbed, but sortation that bounce. Okay, and you can see that the size that would be different for traction, the back load that would be carried out. But for sortation, it should be pebbles. Pebbles, okay, from our definition, you may call it not exactly. It could be also part of the load, bed load, but this is much smaller. This is much smaller, okay, than this, smaller than this. Okay, then the last one, we would call it suspension. We call it suspension. So what is suspension? Suspension means okay, some fine light material, okay, light material are carried along without touching the riverbed. So so for suspension, those mineral, oh no, not mineral, those debris, they will just flow in the river. That flowing, and the most important, they won't touch the riverbed, as the size, okay, of this, that would be very small, and also it is very light. So therefore, if we refer to the definition we mentioned in the beginning, those load that would be the suspended load. Okay, so therefore that would be about the information in your textbook. So all these four type of transportation: traction from the size, traction, okay, that would be the largest boulder, and then sortation, smaller, and suspension, very very small, and then the last one, solution. So that is just about like the mineral that is dissolved in the water. So therefore, four types. So right now you may know that why Mr. Liu mentioned traction first, and then sortation, and also suspension. It is because that is related to the size of the load. Okay, so therefore, let's have a look. On the left-hand side. Okay, left-hand side of this part. So there will be some questions. Okay, so about transportation. Like question 1, which method of transportation will move the load farthest away? The farthest away, of course, that would be okay. So that would be solution. Okay, that will be solution. So you may see the answer here, but it is a little bit small. Okay, solution that would carry the load for the farthest away. Okay, then the second one. Okay, so which method of transportation that consumes most river energy? So therefore, that is very obvious. So when the load that is the heaviest, okay, so therefore the river need to consume the most energy. Therefore, there must be traction. Okay, then question 2. Which type of river load that can transport even when the river had a very small energy? Okay, so it must be the dissolved load. It is because most mineral, okay, will be dissolved in the water. Therefore, the the water or the river, okay, so that would just use the minimum, okay, minimum energy that can transport the water, okay, so therefore there it should be the dissolved load. Okay, then question 3. Which type of load do the following type of matter belong to? Soluble mineral, clay, silt, sand, pebbles, and boulders. Okay, so that would be the classification. Classification. You can see that. Okay, soluble mineral, it means like the dissolved load. Okay, clay, silt, and sand, they are the suspended load. Pebbles, boulders, or bed load, okay, they are the bed load. Bed load. Okay, for this part, I hope you can have a notes. It is because I'm going to give you some extra information. Okay, and then let's move to the next page first. Okay, right now we're going to talk about like what factors that may affect the fluvial transportation. So for fluvial transportation, okay, so here are the factors that may affect the process. The first one, that would be the energy of the river. Okay, so if the energy of the river is higher, so therefore they have higher energy to carry away those load, or to carry heavier load. Okay, so therefore with more energy, okay, it can carry a greater amount of heavier load. So I don't need to explain that. That would be very simple. And then the second one, size of load. Okay, for size of load, there, please mark a star for there. The greater size of load, that is the bed load, the more the energy need to move it. Okay, so it is necessary for us to understand, to note like what should be the size of load. For example, okay, so the background water I choose today. Okay, so for here, that would be the riverbed. Okay, you can see the load there. That would be very obvious what type of load, okay, in this background. It should be the bed load, but as we want to know more, so you may ask, what type of load is it? Okay, so this is like what we call the boulders. Boulders. For boulders, do you have the Chinese name for boulders in your textbook? I know. Okay, so I don't know what is like the boulder. Boulders, maybe I forget it. Okay, so you may check the dictionary by yourself. Okay, for boulders, okay, large piece of rock. Okay, and right now, I'm going to give you some extra information. Just now I said extra information. Okay, so you may mark this. You may mark this. Okay, so this is about the size of load. Size of load. Just now, we talk about like the bed load, suspended load. Okay, so from your textbook, the bed load, suspended load. Okay, and also dissolved load. Okay, so the classification that could be like this. Bed load, the largest, it should be the boulders or the pebbles. Okay, it should be the largest. Okay, so from there, that would be the largest. The largest. And here, it should be like the smallest. Okay, largest to smallest. About the size. Okay, suspended load. Suspended load. Okay, so from your textbook, it mentioned like clay, silk, and also sand. And also sand. And then dissolved load, that would be about some like suitable mineral. Okay, that is what we have just mentioned. Okay, what we have just finished the questions in the textbook. But if we want more detailed classification, okay, detailed classification. Okay, so here that would be what I would like to give you. Okay, so about the size of load, I'm going to talk about the largest first. The largest, okay, when we study geography, when we study like the river, when we talk about load, okay, so the largest, okay, so which type of load that would be like the largest? You may write it down, okay, we may say boulders. Boulder, it should be the largest. It should be the largest. Okay, and then here I would like to give you one more information. Okay, so that would be the diameter. How large would be like the boulders? Okay, if we just use the diameter to show or to classify what could be like the boulders. That is when the diameter, okay, of the piece of rock that is larger, okay, larger than 256 mm. 256 mm. Okay, for this size, if it is larger, we would call it boulders. Boulders. So the largest bedrock, the largest bedrock. Okay, and then for the smaller one, okay. So you may understand this as like the cobbles, okay, cobbles. For cobbles, okay, so the size that would be like between 64 mm, 64 mm, okay, and 256 mm for the diameter. And next, pebbled, pebbled, pebble. In Chinese, this one I note, we may call it 一啲嘅石春啦，一啲嘅卵石啦。Okay, so what would be the size of those pebbles? So pebbles, so normally that is between like 64 mm, 64 mm to about like 2 mm, 2 mm. So even if the rock size that is just like about like 2 mm, 2 mm, okay, like this, we may also call these pebbles. For pebbles, it could be 2 mm to 64 mm. 64 mm, I think that would be about like this. Yes, I think that would be about like this. 6. Is that okay? 1, 2, 3, 4, 5, 6. It could be a little bit larger. I think like this. Pebbles, and then larger. Okay, cobbles, like this. And if it is much larger than 256 mm, also that is about like 25 cm. If it is larger than this, okay, so we call it boulder. Boulders, that would be the bedrock. So traction, okay, so that would be the major transportation method. Okay, so therefore pebbles, and then for next, okay, what would be like smaller than pebbles for this? Okay, actually, we can do more detailed classification, but we're not going to do that in this lesson. You just know the ranking, it would be all right. So after pebbles, okay, so what would be the load? Sand, sand. Okay, so sand, it should be smaller than 2 mm. Okay, smaller than 2 mm. And then after sand, silk, silk. Okay, And then the finest, the smallest one, we won't call it mineral. It is because it is already dissolved in the water. So therefore, you won't see any size. But if we just talk about like the size, okay, it should be clay. It should be clay. Okay, then if we want some numbers, so how exactly like small for those materials, okay? So here I may give you some information. Okay, for sand, you may understand it at, okay, so from 2 mm to, okay, let's see, 0. Actually, I may use this. That would be a little bit better. That is about 1/16 mm. That is about like 0.0625. That is about like this. Okay, for silk, of course, that is much more smaller. Okay, so that is 1/256. Okay, so that could be like this, 0.0039 mm. If that is even smaller than 1/256 mm, okay, all this, that is what we call clay. So therefore, for this, about the size from the largest to the smallest, remember you must know the ranking. You must know the ranking. So you must note, especially when we mention like sand, silt, or clay, you should know that which one would be the largest. It should be the sand, and clay should be the finest, the smallest. Okay, and remember, when we talk about the size, we don't quite mention the dissolved mineral, as there will be no size as it is already dissolved in the water. So therefore, pay attention to the size of the lode. So therefore, okay, this is about the size of lode. The greater size of lode, okay, the greater size of lode, the more the energy need to move it. Okay, then the next one. What factor that may affect the supply of load? Okay, so river load come from the rock fragment erode from the river banks. Okay, so actually that would be from the what we studied before, that would be from erosion. Okay, so where are those load that would be from erosion? Okay, from the riverbed and also riverbanks. Okay, it also came from the weathered rock material. So that would be from the slope that would be on the land. So all this, that would be the supply of load. Okay, so what factor that may affect the real supply of the load? You may have a look about figure 16 there, figure 16. So you can see that what factors or what may lead to more load supplied to the river. So that would be very, very simple. For example, if there's high rates of fluvial erosion, so therefore more eroded material. Okay, if the rock that would be the less resistant, it means that the rock would be easily weathered away. Hot and wet climate. Okay, this one I need to do some explanation. So more weathered material, hot and wet climate. So that would lead to more weathered material. It is because hot and wet climate. Actually, we will learn it later. So if the climate that is hot and wet, it means that the process of weathering, it will increase. Especially later we will learn it, what we call the chemical weathering. So we'll study in our first elective topic for the dynamic earth. Okay, so therefore right now if you do not understand, don't worry, but just memorize this. if there's hot and wet climate, so there will be more weathering. More weathering, it means more weathering material. Okay. Okay, then the next one, steep gradient, steep slope. So therefore, there will be more surface runoff. Okay, and then no vegetation, absence of vegetation. So bare surface, so there will be more soil erosion. And then if there's no lake to trap the sediment, so again, there will be more load in the river. So therefore, all these 1, 2, 3, 4, 5, 6. Okay, so these are the 6 factors that may affect the supply of the load. Okay, so I understand that that could be. So you have to memorize much information about like what factors that may affect the supply of load, but that is not quite complicated as when we study geography. Actually, for the climate, for the process in the river, it means like the erosion, for the weathering, for vegetation, okay, or even whether it is a lake. So that is our basic concept, okay? So that is our basic thinking mind, okay, when we study geography. So therefore, just have a look about this, okay? Just have a look. Remember, 6 factors, 6 factor. Okay, so therefore, that is about the process of transportation. Again, I would say if you have any questions, actually you can type on the live chat box, okay? So your comment will be shown here. So after transportation, so we're going to talk about the last or the next fluvial process, okay, in the river. So it would be what we call deposition. 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 In Chinese, we can call it 沉積啦。沉積. What is deposition? So when we mention like, I hope you still remember. Okay, I hope you still remember before Mr. Liu talked about the fluvial process. Fluvial process. We have already studied erosion. Okay, in the previous chapter. And then just now we talk about transportation. We talk about transportation. And then right now we mentioned deposition. So what would be the relationship about this three fluvial process? Erosion, it means that could be like a minus process. Okay, so the rock will, the size of the rock, it would reduce, and those material, and then would be carried away from place A to place B. So that is like a movement. Okay, and then at last, deposition, it means those load would deposit, will drop, will stay, okay, will stay in certain place. So therefore, it should be like a plus. Okay, we call it deposition. For deposition, it means that okay, so the load that will be deposited on the riverbed. So remember, normally riverbed as sediment, and that's it. Stay in one place. Okay, so let's have a look. What factors that may affect the fluvial deposition? Okay, generally speaking, so a river lost its energy when there is a decrease in the amount of channel water and the speed of river flow. Under what conditions? So the river will lose its energy. That is when the amount of river water that drops. Okay, less water, lower the energy. The first one. The first condition. Then the second condition, that is when the speed of river flow. Okay, when the water moves slower, okay, it lost its energy. So therefore, two. And when the water lost its energy, fluvial deposition that occurred. Okay, so let's have a look. Let's have a look here. Okay, that is like how deposition that may take place. Two condition, one and two, when the amount of channel water that drops. Okay, so therefore, why the amount of channel water that drops? The first one, there will be drop of water supplied, such as when there's dry season, during dry season. Okay. The second one, the water leave the river basin. How? When there's higher evaporation. So the moisture that goes back to the atmosphere. So therefore, the amount of channel water that drops. Okay, here you may not note. Okay, like under what condition? There will be high evaporation rate. That is very simple when we talk about like the concept of water cycle. So we have mentioned that before, such as when the temperature that increase, when the temperature that increase during summer. So more evaporation. So therefore, it could be like less water if there's no new input to the river basin. Okay, so therefore that would be the first one. Then the second one. The second one. Okay, when the speed of river flow that drops. When the speed of river flow that drops. Okay, when a river, when the river flow into a large body of water, such as sea, such as lake. When the river enter the sea, enters the lake, when they enter a large body of water, so the water flow or the speed of water flow that would drop rapidly, okay, to be very very slow or almost zero, almost zero. So therefore, when the speed of water flow that drops, to be it becomes very very slow. Deposition occurred. Okay, so this one, please mark a star. You should know that. You should know that. And then the second one, when the channel friction increase. When the channel friction increase, such as when a river enter a channel with a longer water perimeter. Okay, so that is just about like the theory. So therefore, the speed of water flow that may drop. Okay, and then if this amount of load increase, suddenly if the due to some activities or due to some other problems, okay, when the amount of load increase in this section, so therefore the speed of the water flow it may drop, so therefore that may lead to deposition as well. And the last one also, this you have to mark a star, when the channel gradient drops, such as when a river flows from steep slope into a gentle plain. What does that mean? So that is very very simple, such as what we have learned when the water flow from middle course to lower course. Okay, so the gradient that's dropped, you won't see that. Okay, when the water flow from middle course to lower course. Okay, so the gradient, so from steep slope to become a gentle slope. So therefore, the speed of water, the speed of river flow, water flow, it will drop. So therefore, all this that would lead to deposition. Okay, so that is about like some information. Okay, so about deposition. Okay, so actually, there will be a lot of extra informations for this one. Okay, but I don't think I will explain this to you right now. Okay, I don't think I will explain to you right now. So later, if you have chance, okay, so I will explain this later. And then the second one. So besides, okay, besides the factor that may affect the fluvial deposition, okay, then you should, or we should talk about the process sorting. Mark a star for that one. Sorting. Sorting in Chinese we would call it 一個嘅分選作用啦。So it is necessary for you to memorize this. Okay, so for sorting, okay, please note that for sorting, heavier load require more energy to carry. Okay, once the river start to lose an energy, it will drop the heavier load first. Okay, then the smaller load, and this process we will call sorting. That's why sometimes if you have chance to visit like the river mouth, or even to the beach, you can see that. Okay, so in your textbook it mentioned at the river mouth, the heaviest load form the bottommost layer, while the finest load form the top layer. Okay, why? It is because if you look at this figure 18, okay, when the river flow, okay, first, first, the heaviest material would be deposit first. The heaviest, that would be about the pebbles and sand, pebble and sand. And then the second heaviest, the second heaviest material. Okay, so you can see it like from the silk that could be carried farther away, and deposit later. And at last, the finest, the finest layer, the finest material, it should be the cake. It would be carried out for the farthest away. Okay, like this. So therefore, you can see different layer. And remember, that is what we call like sorting. You can see the step. You can see the step. 1, 2, and 3. Here, remember, that would be the step. Okay. So therefore, remember, sorting. So that would make the landscape, especially in the river mouth. Okay, so we may say it, or sometimes we may say, why there could be like layer and layers, It is about like sorting. Okay, so therefore, let's have a look about the last paragraph for sorting. It's important to note that the deposition does not occur at the mouth of the river. It can occur at anywhere along the channel. Okay, when the river energy drops, such as the inner banks of a curved river channels. So I will explain it later. This one, you will see that in the unit 2.3 when we talk about the features in different sections of the river. Okay, so therefore that would be about transportation and also deposition. And at last, how do fluvial process that change downstream? Okay, so right now we're going to talk about like how this process that may change along the river. So we need to refer to table 4. Okay, on the next page. Here, table 4. Mark this. Table 4. Mark 3 star. Very, very important. 非常重要. It is because that could be like a comparison. Okay, comparison. So what comparison? It is because it explained, okay, clearly what kind of process that may occur in which part of the river. For example, first, when we talk about the upper course, okay, for the energy in the upper course, it should be the smallest. Okay, remember the smallest. Why? It is because the amount of channel water that would be the smallest. Therefore, the energy it would be also the smallest as well. So therefore, let's have a look about like the cross sections. Okay, you can see that. Okay, irregular riverbed, and you can see the large bedrock. So therefore, smaller amount of channel water, then smaller discharge. Okay, smaller discharge. Okay, and the rough channel bed and banks, large channel friction, and the low speed of river flow. Slow speed of river flow. Therefore, the river energy would be very little. Okay, please mark this. Very, very little. It is very important. Therefore, what type of fluvial process that may occur, okay, in upper course? Okay, for erosion, mainly there would be the vertical erosion, or we would call it down cutting. So erosion that may occur in the upper course, but what type of erosion? Please mark it vertical erosion, as there's much potential energy. Okay. So therefore, vertical erosion that may occur in the riverbed. So I may use the pen here. Riverbed is dominant, such as like hydraulic action and abrasion. So lateral erosion is less significant. So you won't see much lateral erosion. Mainly, it should be the vertical erosion, and also headward erosion. Headward erosion. Why? It is because headward erosion may only occur in the river source. Okay. So therefore, that would be the fluvial process. Then the second one, transportation. So as much energy is used for vertical erosion. Therefore, there's only just little energy is left for transportation. 唔係有咁多嘅 transportation 喺上游嗰度會出現嘅啫。So with little discharge, energy is insufficient to remove the large rock fragment in the channel. When the river discharge increases rapidly during rainstorm, the river is able to transport large rock, but that is just about when there's rainstorm. Therefore, for that position, as the energy is insufficient to move heavy boulders, result in deposition. Deposition that may occur in upper course. Okay, in upper course. So you may have a look here. So when the discharge falls after rainstorm, the river stops transporting large fragments and deposit them on the riverbed. Okay. So that's right. Sometimes you will see in the upper course of the river, you can see some large boulders. Okay, large boulders. Why? Because the river cannot transport those large boulders to the downstream. Okay, so therefore that would be the explanation. Then middle course. Compared to upper course, middle course would have greater river energy. Why? It is because there would be smoother channel bed. Okay, so more channel water, and also smaller and rounded rock fragment. So therefore, greater river energy. But for lower course, okay, as large amount of channel water, smooth channel bed and banks, fine and rounded rock debris. Therefore, the speed of river flow in lower course, it would be very high. Then the discharge would be large, and therefore the river energy would be great. Or I would like to add this. It should be the greatest. Okay, in general, it should be the greatest. 下游最大能量，記得最大能量，最細上游，因為冇水，記住啊。Okay, then So what would be the situation about erosion, transportation, and deposition in middle course and lower course? So let's have a look for the middle course first. So as the channel gradient becomes less steep, lateral erosion become more important than vertical erosion. In upper course, we mentioned vertical erosion, we mentioned headward erosion, but in middle course, lateral erosion. Okay, lateral erosion. Remember, lateral erosion. Okay, so therefore, due to lateral erosion will be taking place, so the channel will become wider. Okay, and start to bend. 中游嘅河流會變得越嚟越闊。And here it mentions start to bend. It means it started to change in direction from straight line to like a curve， 開始轉彎啦啲河流，得唔得？開始會what we call like the winding，OK， 轉彎，so that it started bend. And then active lateral erosion is found in the outer banks of the river. Outer bank, it means like if we use Chinese to express this outer bank, you may understand 一個外灣啦，outer banks, inner banks 一個內灣啦。Okay, so I will explain this in Unit 2.3. And then abrasion. Abrasion is the major type of erosion. This one, abrasion, where does abrasion occur? That is at the outer bank. Outer bank. I will explain it later. And then continuous attrition has reduced the size of load. And then for lower course, so erosion is less significant. Okay, no more erosion. Okay, but you can still see sometimes there could be the lateral erosion mainly take place at the outer bank of the river, and there will be just little vertical erosion, and continuous abrasion and attrition from the source has reduced or result in a very small size of load. So therefore, in the lower course, we can see that the silk and the clay frequency as due to a long journey from the upper course to lower course, okay, the size of the load would be reduced to very, very small. So that would be the case about erosion in middle course and lower course. Then transportation. So in middle course, transportation is the main purpose, main process. Okay, mark a star for that. Transportation is the main purpose. So larger load is transported by traction and also sortation. Model is being transported by suspension. So you can see that for transportation, okay. So during the or within the middle course, okay. So that is very important. Why? It is because most the river energy is getting larger in middle course. So therefore, the river, it can transport the load from one place to another place, or especially downstream. And then for lower course, transportation is important. So the load is mainly transported by suspension, as in the lower course. So the size of the load would be very, very small. Okay, or just now we mentioned like the seal and the clay. Okay, then the last one for deposition. Okay, first in the middle course, river may flood during rainstorm. After flooding, so the river deposits sediment. Okay, after flooding on the valley for it has flood. Okay, so therefore, in middle course sometimes there could be like flooding. So after flooding, so deposition that may occur. And then deposition take place whenever there is a drop in energy. So along the river, if there's drop of energy, okay, so deposition may take place, especially at the inner bank of the river. Okay. So here I may draw you a very, very small explanation. Just now at the top right there, for erosion, we mentioned we mentioned for middle course we mentioned erosion, but here we mentioned deposition. Okay, look at this. If it is the river, okay, that flow from upstream to downstream, so direction it would be like this. Okay, on both sides here, on both sides, that would be the river banks. Okay, here that would be the inner bank, there, outer bank. Just now I mentioned 一個內灣外灣啦。Okay, for inner bank, so remember, inner bank, there would be deposition. But for the outer bank, it will be erosion. Okay, the reasons, I'll explain it later. But this is mainly related to the speed of river flow. Okay, the speed of river flow. For this, I'll explain in Unit 2.3. But right now, you can draw this simple figures, okay, for your understanding. Okay, then next in the lower course, deposition is significant. Okay, so please mark this, or this is very important. Okay, so we will say it at the lower course, deposition, that is the major fluvial process in this section. So at which place? At the river mouth and also in the bank of the river, especially for river mouth. Okay, so the speed. Okay, these two also, you may say the speed of flow that's dropped. Okay, at the riverbed during dry season. Okay, it means that the amount of water that's dropped. Okay, and then on the ready for during flooding. Okay, so again, that is about the case of flooding. So where after flooding, after the water that retreat, okay, so the sediment also that would deposit at the floor, okay, at the floodplain. So therefore, deposition. Okay, so therefore, that is about like the comparison between the three causes. Okay, and then at last, for figure 19, here it mentions like how the characteristics of a river change downstream. Again, for table 4, that would be like a comparison, a summary table. And for figure 19 here, okay, this is also like an explanation. Like from the upper course to the lower course, okay, upper course to lower course, okay, all these elements, all these factors, how it would affect, okay, so the fluvial process. Figure 19, figure 19呢個一定要打粒星喺度，呢個一定要明白，係啦。如果你唔明白嘅話咧，咁會係在我哋之後講啊，或者佢提翻之前有啲 concept 咧，會係有啲比較困難嘅。咁所以呢一個 figures 咧，佢入邊牽涉到嘅一啲嘅關係啦，我會話關係啦，或者一啲嘅佢哋嘅唔同河流河段啦，有嘅特性咧，我哋係一定要知嘅，得唔得？例如係咩咧 ？For example。Just now we mentioned like size of load. Okay, so today we mentioned like size of load. From the upper course to lower course, you can see that the size of load that is minus. It means that the size of load from the upper course to the lower course that is reducing. 越近上游，好似而家以呢度咁睇啦，越近上游。唔係應該由上游去到下游個 size 係減嘅，即係由上游開始去到下游 嗰啲嘅 size of load 係不斷咁樣減少。And you can see size load decrease as rock are continuously eroded by abrasion and also attrition. Okay, so therefore that could be like the explanation, so you can have a better understanding about the whole picture of the river. So that's why for figure 19, so remember you should know, you should understand what should be the meaning for that. Okay, so therefore after this, okay, you can see the checkpoint again. It means that we have already finished this part. So for the checkpoint exercise, okay, so please do it, okay, please do it for your own, and then later we're going to check the answer, and you will see that would be the guide to writing short essays. For guide to writing short essays, so actually I would like to do it during the lessons, okay, so we can do it together. So therefore I may not talk about this in the online lessons. So therefore when we go back to school, okay, we may talk about the essay writing and also the unit summary. Okay, unit summary. So please finish this. So later I will take a video to check the answer with you for the checkpoint exercise and also the unit summary. Okay, so 2 pages. And then unit 2.3. For unit 2.3, okay, so I think I will start unit 2.3 in maybe few days, okay. So everyone, please pay attention to the announcement in Google Classroom. Again, if you have any questions, actually you can add your comment in the chat box. You can email me, okay, you can email me, and also you can give me the WhatsApp message, okay. And remember, if you have any questions, as I cannot see you directly, okay, like we have what we have done in the lessons. So therefore, if you have any problems, you must ask immediately, okay. So if I receive your questions, okay, I will answer it as soon as possible. Okay, so therefore that would be the end of this section. Next time we will start unit 2.3. Okay, so I will see you later. Goodbye.